light. Hey there everyone. So today I really do wish that I could have showed you the build on how I made this belt sander, but unfortunately it took way longer than I ever anticipated when I started this project. Literally months just waiting for little pieces here and there, finding the time to go and actually work on it with other projects I had going on and other things. Life got in the way basically. But I finally did my homemade belt sander. I think it's a 78-inch long belt that I got from Amazon. And yeah, as you've probably just seen, it works great. I absolutely love it. I can't wait to put it into use. I still got some work to do on it. Like I need to, I'm going to be showing you a whole bunch of electronic parts that I'm going to build a little box to put in on the front side here. And so just so everything is nice and tidy, because I've got a whole bunch of wires just all over the place right now, and that's not going to work very well if there's going to be a lot of sparks all over the place. But I'm going to give you a little run through on how it got built, and show you a few more of the specific details of it. And this is when I just basically finished it, got it into working order. I'm still going to clean it up and probably paint it just to make it look nice, build the box, and I've got a few other little things I want to do here and there. But in general, it's in working condition. I love it, and I'm just going to show you, give you a step-by-step on how it actually got built. So the very first thing that got built was the frame. This frame, just these 4 tubes, 4 metal tubes that I got from a welding shop in the local area, and that's just it. Bought the tubes, measured it out. I honestly had no clue exactly what I was doing at the time, so I went with about measurements, just with an educated guess, if you will, and turns out it came out pretty much perfect. I have no complaints about it. So that's just it. All we did was weld these 2 tubes together and then put the legs in, and that was the very first step. Second step was basically this part here. Probably won't be able to see it well from the camera angle right here. So the second step was actually making the swing arm up here, the pivot arm I should say, and getting this ready. So that was very basic. Just took a piece of a smaller pipe, this size of pipe, and just cut a little piece here. Put 2 pieces of metal, welded them together on each side so that we get a nice pivot action. The top arm, I had the bar ready, but that was actually the next step, was to start this off. Needed to find a door hinge that would actually work for the wheel, because you do need, this is basically the tracking. For the tracking, I put a door hinge, and I'm going to show a close-up here. For the third part here, I started working on the arm itself, including the hinge. And to give some to give tracking to the belt here, what I did was I took one of the nuts like this, the really long ones, cut it into 3 different sections. I came over here and I welded one to here. There was a hole that goes all the way through to the other side, as you can see right there, and that's what provides the tracking. By turning this, it'll push the wheel up or down. Here, on the bolt here, I welded it to the plate so that it was nice and solid, so that it holds the wheel in place nice and solid. And then, of course, I gave myself I welded on a few little pieces of scrap metal that I had there to give me a handle so I can turn them without using any tools. After that, that was the first piece of this long nut. The other 2 pieces are over here, and these act as a lock for whatever attachment I want to place into here. And the only attachment I have right now is my regular I don't know what this is called, but let's just call it a D slab, a D plate, and this goes in, slides right into there, and then I lock it into place using this bolt over here. And then I want to get another, I ran out of these the smaller square tubes, so I want to get another one, place it into the hole underneath here, and make myself a table that comes out in front here. So first step was the frame, second step was the pivot arm, and then I had the arm here. And one of the last things I did, because I had to set the engine up and all that, was to basically put the springs. I needed to know exactly how much tension I needed and so forth. So this is one of the last things I did. But after that, of course, after the frame was pretty much built, I built this the D section here. And I had quite a lot of problems because the plate here was not at 90 degrees. Anytime when we first tested it out, the belt would slide right off. So had to fix that up, heating up the metal, bending it slightly, and then finally putting it at a perfect 90-degree angle, and to make sure it stays that way, put in the cross sections here. So once this was all built, and it's a very simple design. It's just a half a saw blade, as you can see, welded on to the bar here. Made sure I had enough, plenty of room, so that the weld would stick nicely. And yes, by the way, I did most of the welding. It ain't pretty, but it works. So as simple a design as you can get. But the thing is that it still took a lot of time to get things right. Once I had all of this built, cut up some metal pieces to make the bottom legs here, bolted that onto the wood. I've got the holes in the bottom there so that the bolt heads are not sticking out. That's why I doubled up here. So the bolts are sticking out of this piece, but this piece has larger holes to hide the heads. And finally, the engine. Oh boy, did that give us a lot of trouble. This is the engine of a treadmill. It runs on DC power, which I'll come back to later. But that's just it. The I don't know how you call this, but the wheel that was already on there, the metal wheel that was already on here, was not thick enough. Let's see. So that's just it. As you can see, the plastic that we put on it here is slightly larger than the belt, just to give it a chance to move around a little bit. And if you look with this angle, you should see that the plastic goes way beyond the metal wheel that was already there. And well, that's just it. So since the metal wheel was too thin, we weren't able to use it as it was, so we had to modify it. So what we did is that we basically just took a piece of a very old barrel, blue plastic barrel, and chopped it up, heated it up to take the shape of the wheel, and then we drilled through, gave them a tap so that they'd be threaded for the screws, and that's just it. Finally put the screws in to make sure the plastic never leaves the wheel as it's spinning, and it can spin quite good actually. I get good speeds on this. I don't know how many RPM, but it's enough to work metal, so that's all I really need to know. After that, it was unbalanced, had a lot of vibrations. So we had to go and make it spin with a chisel and just smooth everything out so that it wouldn't bounce all over the place. Okay, so this is the very basic design of the belt sander. It seemed simple at first, but there was a lot of different steps to take. If you have any questions about any parts of the step, leave a comment. I'll do my best to answer all of them, because that's just it. I had to run around to get bolts that I didn't know I needed, nuts that I'd run out of, all kinds of stuff. Now, where I had a big problem. Now, where I ran into a big problem is that I'm not very good with it. I'm really not good with any kind of electrical system and all that. A computer I can understand, I can take one apart, I can put it back together and all that. But when it comes to like AC versus DC and switch controllers and all that, I had no clue. So I educated myself online. Thankfully there's a lot of people that are way smarter than I am. And they showed me a few things. Well, first of all, we did try as good as possible to use as many of the pieces of the treadmill that I received to make this. The boards are actually the bottom of the treadmill, but unfortunately, most of the electronic equipment, the motor was still running good, but we weren't able to salvage the control boards, which I would have loved since I could control the speed in a much more efficient way. But I found a solution to that. And I had to go on Amazon. Oh boy, a whole bunch of mix up there. And I ordered myself a little control box like this. So it ain't much, but it does the job. Might need to get a better one though, because it only makes the wheel turn when it's like really high. So I think that I can just replace the little thing here. Not sure. I'm gonna look into it, but for now it still works. And the thing is that's just it, is that we salvaged, like I said, I need a box to put all of this stuff in. So we salvaged the power supply and the switch from the treadmill itself. So we were able to salvage this and got it hooked up. Then I can control the speed with this. Really high. But another piece that was missing was that... Okay, so another piece that was missing was this. And this may not seem like very much, but it's an AC to DC converter. So without this, I wouldn't be able to get the engine running, and this was basically integrated into the treadmill control panel, which I wasn't able to get to work. So I had to go and buy this separately. I think it only cost me like $3 on Amazon, so it wasn't that bad. And as you can see, it works. So now I've got an on-off switch, I've got a speed controller, and I've got this that makes sure that the engine runs. So I'm pretty much all set all over the board. All I need to do now is build the control box that I'm going to be putting. I'm going to be putting the control box right here, so it's easy access. Don't know if I'm going to put something to cover the engine or not, the motor, but I've got a whole bunch of belts here that I bought from Amazon. So I've got a whole bunch of belts here I bought from Amazon. They're all 80 grit though, but apparently when you make good knives, you go through these like nothing else. So looking forward to that. When it comes to putting the belt on, it's pretty simple. Like I said, the springs were basically the last thing I put because I needed to know where the engine was placed properly and all that. So all I did was weld on some bolts here, and I put 2 springs just to get that little bit of extra tension. Putting the belt on is pretty simple, just need to have it put it in the right direction. So I put it in front before. Come here, press down. Oops. And voila. Belt is on. Let's turn it on. So yeah, it is extremely loud. Oh, I put the belt on backwards. That's might be a problem right there. So it is extremely loud, and there's still some vibration in it. But once it's bolted down to my actual workbench, because this is not my workbench right here. When it's actually bolted down to my workbench, a lot of that vibration goes away. Right now it's just because I've got it on the table so I could spin it around for you guys. And that's about it. a few months of work here and there, and I've got the machine I wanted. So, need a tool? Make a tool. As one of my favorite YouTube stars says. So, thanks a lot for checking out the video. And like I said, if you I know this didn't explain very much. I hope it showed you the general parts of it there that you might be interested in. And I'll give you a good little 360 view here. And of course, if you have any questions that I might be able to answer, feel free to write them in the comments, and I'll do my very best to answer some of them for you. My workshop is kind of small. Having trouble with this. But yeah, that's it. So, see y'all next time.